I'm back for 2020, hopefully to make a few more videos. Just got in from a workout and saw some emails that I got, and one was with a question. So I thought I would get going again. This is obviously this is a rather new question. For all of you that have asked me questions that I haven't answered yet, I'll try to get to those kind of as in an order that I prefer to answer the questions. For this question, I got actually some data in and some specific questions to their data. So I'm going to go through that. I'm going to put their data up, and this is a step test that this individual did using the Human Hex. It's a 5-kilometer incremental step test. Every 3 minutes, they go up 1 kilometer per hour to exhaustion. Okay, and even though the dynamic range is rather small, as you can see, it's between 60 and 70%. It doesn't really move. But you can kind of get the feeling of the pattern. You get this kind of increase and kind of this decreasing. You get this slope, which is what you expect from NIRS data during incremental step tests. So like I said, the Human Hex is measuring something accurately here. You're getting what I would expect. The problem is, so the question is linked to assessing limitations in your performance, and often with NIRS data, or at least lots of these Moxy users, they talk about utilization and supply limitations. So is my performance being limited by my capacity to use the oxygen I have, or by my capacity to supply oxygen? And that usually has to do with how your SMO2 changes. Now, in order to make those assessments, you need to be able to gauge what this 0 to 100% scale even means. Because if I look at this picture, I would make the assumption, well, this person is obviously limited by their ability to use oxygen because they have 60% oxygen still available to them at the point of exhaustion. That seems to be a lot of oxygen around that's not being used. So, inference, the best explanation, they're limited by their capacity to use oxygen. That might be true. However, the problem with this is that this range overall is really small. And as I'll put some links to other videos that I've made about this, is that I don't trust that the Human Hex in this case, but other NIRS devices do this as well, that they really have a 0 to 100% scale that is muscle oxygenation, so SMO2. I think it's more of a tissue saturation index. So it's just all the tissues being used because in a homogeneous mass. And the problem there is that fat tissue doesn't really metabolize oxygen the way that muscle tissue does. It's not metabolically active, so it just has blood circulating in it, but it tends to be highly oxygenated. Or same with skin tissue. Skin tissue then also increases with blood circulation that is actually then highly oxygenated, which actually like counteracts what in the overall scheme of things has an opposite direction to what muscle tissue would have. And so for me, what's happening here is if I want to make a claim about limitations, I have no trust that I'm really seeing what's happening in the muscle, and so it's difficult for me to make this claim. With the Moxy monitor, under 15 millimeters of fat, I have much more confidence in this, that I'm really getting a range that's somewhat accurate in my muscle oxygenation. So I've been getting values at 60%, for example, with Moxy. I would be much more willing to say I would assume that you're limited by your ability to utilize oxygen. In this case, the Human Hex, I'm not convinced that I can make that case, or not as strongly anyways, because again, this scaling issue. Now, to kind of further advance this case a little bit is the individual then also sent this data, which is a mixed modality workout with like thrusters and CrossFit stuff, I'm assuming. And then asked, well, here they have a bigger range, which is true. So they're kind of going from the 70%, which we saw before, but it kind of goes down into the 40s in one case, just below 40. Now, still not a big dynamic range, but you get more. So there's obviously more capacity there. But still with this very high intensity exercise, with a lot of contraction of the muscle, limiting blood flow, you get all this variation in THB, which is you're seeing that there's a lot of pressure going on the blood vessels. It's still not getting down very far. which is rather unusual. Now, again, this again depends on the individual and things, but usually during these types of exercises, somewhat fit people get rather low values, at least on NIRS devices that really measure muscle oxygenation. And this is not happening, which again further goes to the case. I just think the scale isn't accurate. The measurement in itself is accurate, the scale is not. What I would argue this, if you put these pieces together a little bit to talk about the limitations, that obviously there's more range available than what was shown in the endurance test. You could then deduce perhaps that's hinting towards a limitation in utilization, because you have very strong endurance athletes get very low muscle oxygen values during cycling and during squats, for example. Whereas you get less fit people often get much lower values during kind of mixed modalities or squats or something like that than they do endurance. So the limitation is clearer in these kind of endurance type tests, because the blood flows more freely. So it's harder to push those oxygen levels down if that is your limitation. So to answer the question clearly is using this data, I have problems saying that what the limitation really is. I don't really know if this is a utilization limitation. It might very well be, it's possible, but my level of confidence is not that high. I hope it helps. Two things. First of all, it helps with people understand the scaling issue again, this example, and why it's useful to have a scale that reflects somewhat accurately what is actually happening in the muscle, not just the tissue as a whole. And it helps maybe show some thoughts that I put into how to maybe look at limitations. So thank you very much for listening. I'll try to get some other questions out, and if you disagree with me or have any comments, always add that to the comment section. Thanks. Bye.